Hi everyone, welcome to the new video. This is the part 3 of the shell coding series. Today we'll be covering the rest of the shell code that is actually executing notepad or calculator using the assembly program and then actually extracting the shell code from it. We actually reached to the WinExec function in the last video. So we are right now at the WinExec function. We need to actually push in the arguments or push in the arguments that we need to execute a command. In the sense, I want Notepad to be opened up, so I will be pushing Notepad into the stack and then sending that as argument in WinExec and trying to open it. If I just check out WinExec WinExec method, so this is how WinExec looks like. So you first parameter is the command line, that is calculator, Notepad, Brave browser, whatever you want to open. And second line is how do you want to show it, like it's a full screen, minimized, or should it run in the background, things like that. So now we know what needs to be done. First thing is to actually push notepad into the stack. So what are we going to do? We are going to, okay, before that I need to give you some context that notepad is what I'm trying to get in. This is a 32-bit assembly ratio, so I can only put in note and pad as two separate things because we can only put in uh, four characters in one go because it's a 32-bit system, or like we use 32-bit registers. So what we are going to do is that we are going to add a null byte at pad, so that the way we wrote shellcode, we made sure that there are no null characters. So we need to make sure that there are no null characters here as well. Since this follows little Indian convention, we need to push in pad first and then note. So here is how it's going to look like. So we're going to push in 0x01. So that is the byte that we don't need, or which is going to be reduced later on. Then D will come first. So I believe that will be 64, and A is next one, and P is after that. And after that, I'll push in note. So that will look like E will come first. So 65. Then T will come after that, and after that it will be O and N, that is 6E. This is how it's supposed to look like, but we you see that there is a byte 01 that is present. We need to decrement that to make it 0, so that it at the end of the day it looks like just notepad. It ends with a null character. All right, so how can we do that? In order to do that, you just need to make sure that it is PAD and this is NOTE. So we need to decrement the last byte, that is 01. So decrement byte, we're going to put ESP plus 3 because that is the last. So ESP plus 0 will be 70, ESP plus 1 will be 61, ESP plus 2 will be 64, ESP plus 3 will be 0x01. So we'll decrement it. This will look like notepad. Now we did so the how WinExec takes in arguments. That is, first argument is notepad, and second will be the size that we want to display it as a normal full size page or full size application. So how are we going to do it? So we should put in the last argument first. So going by that way, so push 0x1, that is be maximized. Push. I didn't do one thing, that is I should move ECX. I am actually moving the value from stack to ECX so that I can push ECX as the next value and then call EAX because that is where WinExec is. Now if I compile this and I run it, it opens up the notepad, as you can see. Perfect. Now we have our program in place. So next thing we should do is actually go to the shell code. So I have already written a basic declarations here on the basic declaration, basic structure here. So I am taking the full path of the executable and I'm reading the bytes from it. I'm doing a data file dot read. To give you more context, I need to actually open up the shell the right shell file in PE loader to tell you where we exactly need to go. It's kind of similar like what we did in kernel 32 and find WinExec, but here it's different. We don't want to be going into any of the headers. We want to be going into the image section, get the virtual size and get the pointer to the raw data. We actually want to find where the actual set of code is or the real executable is, not even real executable. The best way to say is that the core logic of the program is, and extract the start to end of the core logic. So that is actually stored in that actual size is there in the virtual size. We don't want the raw size of the data because that will include paddings. It will be a larger data. We don't need any of that. We just need the portion from of whatever code we have written, which has been compiled. So we will point to the raw data and we will add the virtual size to it. And from the pointer to the virtual size, the pointer is the data that we need to get. So in order to do that, we will follow the same things that we did, but here in Python, it's a bit different. We'll do first a header of set of data x0, x03, 0x3c. That will get us to this is 3c. That will get us to ND header. Header we know signature is a dword of 4 bytes. Image 500 and then we'll do image file header. And in here, machine and number of sections are just word sizes, and these two are D words. So that is 4 3 are 12 plus 2 plus 2 that is 16. And we need the size of optional header because we won't be computing the size of the entire optional header. We'll be just taking the entire size from here and we'll be adding it. So that is the next thing we need to do. That is we need to get the size of the optional header. So 16 plus 4 that is 20 from the header will reach us to optional headers size. We'll take the value in. That will be the next step. So size of optional header is equal to in from bytes data header offset plus 20 reaching till size of the optional header, and size of optional header is a D word, so you just need to do 2 and it's of a little Indian format. Now we have reached here. Now we need to reach till virtual size. So we haven't added the entire ND header size. Entire ND header size is of size 24. That is signature plus image file header. That is of size 24. You can just compute it by checking uh, image file header. So if you add all of these together, it will be 20 plus uh, it will be 20 plus signature is 4. That is 24. So we need to add all of that as well. So in order to reach the text section, we add size of optional header plus header offset plus size of NT header. So that is 24. Now we have reached till text section. And in text section, we need to get the virtual size. So we can just compute that. I'll just go here and I'll clear this Python 3 and we just compute those values from here. That is int of 0x178 no 180 minus 170x178, that is 8. So virtual size is of a size 4. As you can see, RVA relative virtual addressing only starts at 184. So we need 4 more bytes. So virtual size is of size 4, and we need to find the pointer to raw data. That is and 0x18c minus 0x178. So that is at 20 from the name. So once we have all of this, we can just add it. So the next thing to be is find the virtual size. So text section plus 8 plus 4 as we have found here. Next will be to actually get the pointer to the virtual size, that is text section plus 20, that is also of size d word 190 to 195 as you can see. And the last thing will be to actually get the shell. So that is pointer to virtual size and pointer to virtual size plus the virtual size itself. So you will get the exactly the execute the core logic in the shell code. And finally, I'll just print the shell code. I'll exit this and I'll just run this code. And this is the actual shell code that we obtain. I think we have a notepad open or that can be easily fixed. We can always run our shell and open notepad. And this is how the shell code actually looks like. Now that we know how shellcode really works in Windows, it shouldn't have any null characters. You're actually grabbing the uh, pointer to the raw data and you're just getting the pointer to data plus the virtual size. So this is what a shellcode in Windows really looks like. Next videos, I try to use this to do simple buffer overflow programs in Windows, buffer overflow exploits in Windows, just to showcase that this actually works. So this actually covers the entire shell coding tutorial at a very basic level. I hope you really liked it. Please do drop in your comments and let me know if you liked the video or not. Thank you so much for watching.